Hello, everyone. Welcome to this week's SIG scheduling meeting. And this meeting is being recorded. So be respectful to each other. I'm going to share my screen. And today there's not too many items on the agenda. The only one is by Hiba that she wants to present some interesting idea to leverage the scheduling framework to do some pod spreading, flexible pod spreading policies. So Hiba, are you ready? I can give you the co-host so you can share, or you can check if you can directly share.
Hi, thank you so much for hosting us. So I have Anish, who worked with us in this project. Anish will start the presentation and the demo, and we will be here for any questions. Please, Anish, go ahead.
Yeah, Anish, could you give a try if you can share directly? If not, I will give you the co-host.
I can actually
you can share. Good. Yeah, go ahead.
Awesome. Thank you. Yeah, thank you again for having us on this call. So I won't take too much of your time. We just basically want to introduce this new project that we worked on using the scheduler framework, and then also just show a brief demo. And then I think after that, we can probably talk about like what next steps are and if there are any feedback, right? So placement policy scheduler plugins. On a very high level, it basically provides a knob for cluster admins to define a subset of workload should run on a particular set of nodes. And then in terms of background, the motivation for this is today in most of the cloud environments, when you deploy a Kubernetes cluster, you have regular nodes which stay throughout the lifetime of the node cluster, which probably go away during upgrades and all that, but the node is bound to stay, right? And then there is this new notion of ephemeral nodes, like so Azure Spot VMs and like different cloud providers provide VMs, which get added to the cluster, but then there is no reliability in terms of how long it stays. So basically, if it's not used, then the node might go away. And there is no way you can make sure that it always stays throughout the lifetime of the cluster. These VMs are less expensive compared to the regular nodes that's used for the Kubernetes clusters. But again, in terms of reliability, there is no way to ensure that they're always up and running. If a cluster admin wants to use these nodes for scheduling their workloads, they cannot put all their workloads on these nodes, because if they do that, then if the node goes away, then all their workloads are down. And today, if they want to find a way to deploy, like, let's say 50% of pods on regular nodes and 50% of pods on these nodes, like which can go away, there is no way to do that. So what we did was me and Heba and a few other folks worked on this. So basically, we used the scheduler framework to develop a plugin that will allow users to define how much percent of workload should land on a particular set of nodes, like subset of nodes. And then the way we are enabling this for users is through a new CRD called placement policy. I'll go over that next. But what we do is we offer two different modes. One is called the best effort mode, which basically uses the scorer plugin. So we use the pre-score and the score extension points in the framework. And then the other one is called strict mode. So in the strict mode, what we do is we actually filter out nodes based on the internal algorithm that determines how many pods are already running on a particular subset of nodes. In case of best effort, we are only scoring. So based on the current state of world calculation, we just determine where this pod should likely land. And then we basically provide the node with the highest score if we think this is the node that the pod should land. And then after that, we just let it to the other default scheduling decision to where the pod lands. So right now we provide a way for this to be deployed as a secondary scheduler to the cluster. And then this is the placement policy that I mentioned about, right? So in terms of the fields that it has, we have a weight. So if you have multiple placement policies that match a single pod, then this weight is used to determine which placement policy should be evaluated for this particular pod. Enforcement mode is best effort or strict. So if you do best effort, then we will be making decisions on score. And then if you use strict, then we will actually be doing filter. The way you actually define which subset of how much of your workload should run on which subset of nodes is basically using pod selector and node selector. So this builds a high-level abstraction where this could just work with ephemeral VMs and regular nodes, but also if you just have a single cluster where you have all regular nodes, but you just want to label them as different workload pools, then you can do that with labels, right? So in pod selector, you define which pod this placement policy should match for. And then in node selector, you can say which node you want this decision to be for, which subset of nodes this decision should be made for. And in the policy, action can be must or must not. So if must obviously means that the pod should land on this particular node percentage of pods, and must not is on the contrary. And then target size is where the user defines how much of their workload should be running. So I'm going to show a quick demo of what we have. So in this, I've already created a kind cluster, which mimics that scenario that we talked about. So it's a 3-node cluster in which I have labeled 2 nodes as want. So I want some of my pods to be landing only on those nodes. And then the 3rd node is just labeled as unwant. What I'm going to do is I'm going to deploy our scheduler plugin there. This puts the plugin in the kube system namespace. Okay, so now that it's running, the next thing that I'm going to do is actually show you what is the placement policy that I'm going to deploy. So here I'm using enforcement mode strict, and then I'm saying any app that matches the label nginx, kick in and then make the decision. And then node selector, I'm saying 40% of my pods should land on the nodes that are labeled want. So which means if I deploy a pod with 10 replica sets, then 4 of my pods should land on the first 2 nodes, and then the remaining 6 should land on my last node. So I'm going to deploy this in my cluster. Okay, so I've created the placement policy, and then next, let me show you the actual replica set that I'm going to deploy. So here I'm deploying a replica set, and then it has 10 replicas. So based on the placement policy we just deployed, there should be 4 of them on the first 2 nodes, and then the 6 on the last node. And also because we are deploying this as a secondary scheduler, the user would provide the scheduler name so that this is the scheduler plugin that makes the decision. Okay, so that's deployed. And then the next thing that we're going to do is check the status for this. Okay, so if we look at this now, like the first 4 pods are on the 2 nodes which had the label want, but the remaining 60%, which is 6 of the pods, actually running on placement policy worker 3, which was the node labeled unwant. Yeah, this was a pretty quick demo that we wanted to show there, get feedback, and then also see, like, just talk about next steps.
Okay, I have a few questions.
Yeah, go ahead. I also have a few questions. Yeah, go ahead.
So why do we need a scheduler plugin to do any of this? And let me explain what I mean by this. Like at the end of the day, it's about your replica set, how it labels or like associates affinity with the pods that are being created. So at the higher level, the problem you're trying to solve is that for a specific group of pods, you want a percentage of them to land on VM type X and another percentage on type Y. And you can do that simply by monitoring how many pods you have, and then just associate the node affinity with each group based on that percentage. So if one way to do this is, for example, having 2 deployments. And then your controller will basically make sure that for these 2 deployments, like you have a total number of pods, and then deployment 1 is for preemptables, it has a percentage, and the other one. Like I guess my point is you can do this at the higher level. You don't really need a scheduler to be involved in this.
Right. I mean, you can do that with multiple deployments today, right? That's right. And then also, I think there is a way where you can do something like a webhook, basically to determine where to land pods of the same deployment. But I think we just wanted to extend the existing framework to make it easier for users to configure. Like if they don't want to have multiple deployments for different set of nodes, they could just use a single deployment, but make decisions based on this CRD and say like, hey, I just want this percentage here and that percentage here. And that would just work out of the box for them.
Right. I mean, but my question here is like, instead of changing the scheduler, why not trying to scale, like to propose something in the deployment API and controller to do something like this? It doesn't strike me as a scheduler problem. This is more about how you're going to create your pods and how you're going to associate affinities to them.
I can comment a little bit. Actually, yeah, as Abdullah mentioned, this is also some open source software like OpenCruise is doing. They control this kind of pod placement on the controller side. So they have some specific deployment as a CRD. So this is definitely one way. But in that way, it's not oriented on the pod level. You have to control that in your CRD level. So that means you have to use your own CRD. It's not universal applicable to pods. So that is how I see this problem. So basically, yeah, there's trade-offs on each solutions. One, either on the controller side, either on the scheduling side. Yeah, but that is the trade-off.
What is the trade-off like here? What are you giving up?
For example, if you use the controller solution, you have to define the CRD. But some users
but like,
doesn't want.
The idea is to actually propose an API in the core deployment, in the core Kubernetes deployment API to implement such a feature. It is like, you know, in cloud deployments, I totally agree. Like this is something we need. And I think I would encourage you to actually make a proposal, an enhancement in core Kubernetes to allow having these, you know, capabilities. And the thing is, like in my mind, like Kube Scheduler is a pod to node, you know, placer. We already have the primitives that sends a pod to a specific node. So we could use that, right? And just build on top using the application controller to do whatever percentages and like balancing you're looking for.
Yeah, if we can push this API semantics to the core API resource, then yeah, there's maybe a better way. Yeah, I agree. It's just that maybe pushing the API to the core maybe has a long way to go. So some projects choose different way, either choose on the controller side, or choose on the screen side. Yeah, that's the current status.
Yeah, I think if there is actually like interest in having this on the core side, like that's definitely something that we can look at, right? Like I think the scheduler framework and this project just helps us throw something together that we can show that works, like basically with what we want to do. But again, the long-term goal, having it something in the core API, that'll be really great. Like if we can move these pieces there, then it just benefits the wider ecosystem. They don't have to deploy the second scheduler and everything, right?
Yeah. Right, like, yeah, I'm not like trying to discount the effort. I think this is great, and it shows how powerful the schedule framework is. But as you mentioned, having this, if you are to make this available in core Kubernetes, I think you're going to get pushback on having the plugin itself being part of the default scheduler, for example. I would expect that this to be implemented at a higher level, like using the deployment controller. Maybe not, I don't know, like, but it is definitely like a good solution to have it done at a higher level.
Yeah, I guess in the Republic side controller.
Right. Yeah, that's kind of what we're really doing here. But in terms of having it there in proposal, like which SIG would that be? Like, would that be with, we go through SIG scheduling if this is something that we want to propose, or?
SIG apps, I think.
Okay.
Yeah. So I have some other questions about the current implementation based on the schedule plugin. So one is I suppose there is a timing issue. So in your demo, you suppose your scheduler is aware of the placement policy object, right? But what if the user just created these two things, placement policy as well as the workload at the same time, and it just happened to be that the pod hit your scheduler earlier than the scheduler aware of the placement policy. Because
So,
you don't have a strong correlation between your placement policy with your pod. You don't tag a label or sort of thing, right? So you just, yeah, it's transparent to the user or to the scheduler. So it depends on the order, how you, yeah, I'm not sure you get my.
no, I think I understand actually. Like,
Okay.
so today we don't fail. Like that's what we do. Like today if the pods come in, like if they say the scheduler name is placement policy scheduler, and if they still come in and if there is no matching placement policy, we actually don't fail. Like we just say like, hey, look, I'm not making any decision because I just don't have any CRD provided from like custom resource provided by the user. But I think if we actually want to going forward, maybe that is what we need to do. Like if we need to decide if you actually want to fail on it, if there is no placement policy matched and if a scheduler name is provided.
Yeah.
But today, yeah, we just like log error and say like there's nothing we are going to do.
Not quite. Not quite. You fail the pod. It's just that some pod may want to use the policy, some pod may not want. But the correlation is very, very lightweight. So my point is that in your schedule plugin, you don't know if there is a placement policy present or not. It quite depends on the creation order, right? So you may want to have a guarantee that if a pod really wants to be enforced by the placement policy, you should have a sort of a mechanism to ensure the schedule plugin is aware of the placement policy. Yeah, that's my point. I think this is also a common design problem in a lot of plugins. We also see this in the schedule plugin repos. Some plugins have timing issues, like which object is created first, and we need to guarantee we are aware of that CR objects.
So how do they handle it today? Do they just ignore it?
So for example, I can take code scheduling as an example. Like the pod is associated with a pod group, right? So right now, the solution is that the pod is being tagged, being labeled with that pod group name, so that when the pod comes in, I know this pod wants to be enforced as a pod group semantics. So I will check whether the pod group exists or not.
Got it.
So that's but I don't think it's a perfect solution. We may discuss more to find them. Yeah, maybe better solution. So right now, in some other plugins, it's just labels. Okay, another question is, who is responsible for deleting the placement policy? I think it's a one-off object. Well, suppose you are running a job, it's a run to completion path, and those paths wants to use this placement policy. So I guess you have to manage the life cycle of the placement policy, and you may have wanted to delete this when the job is completed.
I think that would still depend on the cluster operator, right? Like, or are you thinking something like an owner reference where it's just tied there, the job is the owner for the placement
I just
policy?
want to figure out who should be responsible for like deleting the placement policy.
Right. So the cluster, I mean, the policy creation and deletion right now we're thinking would be the cluster operator, or like whoever is the namespace admin. Like if they want to use it, they create it and delete it. And then the matching is anyways done based on the label. So if it exists and they're deploying different jobs using different labels, it should still not affect those jobs.
Okay.
Yeah, we didn't want to interfere the life cycle because sometimes the admin needs to apply this policy just for testing purpose or for some staging purpose, and after that he can remove the policy. Otherwise, they wanted to apply it for the whole production workload, so they can have it for as long as they want.
Okay, so it's the user's responsibility. Okay. The last question is that in your demo, I want to know how the pods is being created step by step. So in your example, you have like two types of nodes, right? One is no want, one is unwant. So in terms of when you schedule 10 pods, is that you're scheduling one on the node with want, and then when the next and unwant, or sort of like this kind of how the pods are going rolled out?
Yeah, so this was actually like we had to go back and forth and decide on what we wanted to do. But I think the final decision was if a placement policy matches with the pod, whatever is defined in the placement policy is what we first want to accomplish. So the user said they want 40% to land on nodes equal to want. So first we try and get the 40% on that node, on those two nodes, and then the remaining 6 will just be thrown into node equal to unwant.
That sounds a bit tricky because you may don't know the overall number of the pods because you just use a label selector. You can't just look at the replica number of the replica set. You have to look at that globally.
So that's what we're doing right now. Like actually,
Okay.
like right now we're getting the current state of world when we make the decision. Like we are moving towards a model where we want to maintain an in-memory state. But right now we're actually getting everything that's there in the cluster now. So we get all the pods that's there right now, that's already scheduled in the process of being scheduled, and then we make a decision based on that.
Okay, anyway, it's very detailed, technical details. Yeah, we can discuss offline.
Yeah, we can follow up on the chat for this one.
I have a follow-on question on that. So did you consider, like, when you schedule pods, do you consider that pods priority, like, because you mentioned the 40% nodes, those nodes are not reliable, right? They could be deleted anytime. Do you consider schedule critical workload to those 60% more reliable nodes, and those non-critical workloads to that 40% nodes, which could go away anytime, or something like that?
Yeah, that makes sense. Like, I think the idea was if the user says 40% on this, it could be that they're saying 40% on the regular nodes. Like, I mean, in this demo, it was 40% node want, but it's possible that they just say 60% and then they say node equal to want, right? And then that could just be the regular set of nodes. So for us to determine which node is actually the regular node, and which is the ephemeral node is not something the plugin can do. So what we decided was instead we'll just let it to the user. So if they say must, that means they want something on this, absolutely. So we will just go do that first, and then the remaining can go and land on any other node. Like that was the idea that we went forward with. But yeah, all these questions and the feedback was really helpful. Like, I think we would also like to help in the conversation around the order in which the CID is created. So like we'll try and pitch in on that conversation as well. And then thank you for the next steps. Like we will try and reach out to SIG apps and see if this is something that they're interested in adding.
Yeah, I think, yeah, as Blizzard said, it's a common requirement. So if we have that semantics on the core API resource, that would be pretty helpful. All right, there's no other item on the agenda. So we have 4 minutes left. And if you have anything you want to discuss, you can just raise it up. If not, I will just give the 4 minutes back to you. Okay, seems no other items to discuss. All right, see you in next 2 weeks. And thank you for Hiba and Anish to present.
Thank you.
Thank you.
Bye.
Yeah, thank you. Have a nice day.